Let's talk about the instrumental analysis you're going to be doing this week to quantify the iron present in your vitamin tablet. To run this analysis, we're going to be doing instrumental analysis for the first time, and we're going to be using an instrument called a spectrophotometer. So a spectrophotometer, sometimes just shortened to spectrometer, is an instrument that measures the transmission of light. And ultimately, the instrument will allow us to relate the amount of light absorbed by a sample to the concentration of the analyte present in that sample. The spectrometer that we have in our lab that you're going to be using this week is the Thermo Fisher Helios Gamma spectrophotometer. So that's shown in the picture to the right. That is the beige box. Spectrometer, seen from the top, has two basic halves to it. The left-hand side is the sample holder, so you'll raise the lid, and that's where you'll insert your sample, which we'll talk about in a second. And obviously on the right, we have the control panel. So your first job is to initialize the spectrophotometer. And the very first thing you'll do is turn the spectrophotometer on, which can be done through a throw switch on the center back of the instrument below the power cord. Once the spectrophotometer is turned on, it will begin to initialize, and the instrument will go through its initialization process. It will go through a checklist, and as it moves through each stage, initializing the optics, testing the tungsten lamp, initializing the monochromator, etc., you'll see a check mark appear next to each stage, and once it's made it all the way through the checklist, the spectrometer will be initialized and it will be ready to take a measurement. Once the spectrophotometer has successfully been initialized, you would transfer control of the spectrophotometer to the computer by pressing the remote button, which is one of the manual entry buttons below the main menu here. At this point, you log into the computer and you open up the Vision Light software from the desktop, which is the software that controls the spectrophotometer. So pushing the remote button transfers control of the spectrophotometer over to the computer, and then you can run it using the Vision Light software. For our analysis this week, you would put the spectrometer in scan mode, which will allow us to take an absorbance spectrum throughout the whole visible range of the electromagnetic spectrum. After hitting OK, you will go into the main Vision Light interface in the scan mode, which will show you several boxes. It will show you a window which won't yet be filled with an absorbance spectrum on the right-hand side, and then it will give you a new computer control menu on the left-hand side. So for our analysis, to quantify our iron, we are going to measure the absorbance of our solution at a specific wavelength, which is 510 nanometers. So 510 nanometers corresponds to green light in the visible spectrum. So we are measuring how much green light is absorbed by our sample. Our iron complex, our iron phenanthralin complex, absorbs most strongly in the green region of the electromagnetic spectrum, and as a result, it appears red to our eyes. In order to capture this region of the spectrum, you're going to have to tell the spectrometer what range of wavelengths you want it to scan through. So under the scan menu here where it says Start, you would scan over the whole visible region of the spectrum, and so you would tell it to scan from 400 nanometers to 800 nanometers, those are roughly the cutoffs where the human eye starts to perceive blue light, short wavelength light on the 400 nanometer side, and red light, 800 nanometer wavelength on the right-hand side. Once you've set these parameters, don't take your measurements yet, but give the system a full 15 minutes to warm up. The warm-up time is mostly to let the emission from the tungsten and deuterium lamps, the light source in the spectrometer, stabilize. We want stable emission from our light source so that our absorbance won't be fluctuating as the experiment goes on. So you give it 15 minutes of warm-up time. Then you're going to come up here to the Measure Samples button after loading your samples and giving the spectrometer sufficient time to warm up. And the Measure Samples button is what you'll click to start your analysis. Once you click Measure Samples, there'll be a menu that pops up which asks you to tell the instrument how many samples have been loaded into the sample holder and where in the carousel it should expect to find the samples. Once you've loaded your samples, you'll hit Start on the pop-up menu, and as the analysis proceeds, you can hit the Auto Scale button down here so that you can observe the absorbance trace displayed in real time in the right-hand panel. In terms of your sample preparation, this is very straightforward. You just have to transfer your iron solution to an appropriate sample holder. The sample holder that is used for spectrophotometry analysis is known as a cuvette. Cuvettes can be made out of various materials. For quantitative analysis, you always want to use a quartz cuvette if it's available. Quartz cuvettes are extremely transparent in the visible and UV region of the electromagnetic spectrum. They're very high quality optical glass, and they won't be degraded by the presence of organic solvents. The solvent we're using this week is, of course, water, so the material of the cuvette is not a huge concern, but quartz cuvettes generally give the highest quality optical spectra. So you always reach for a quartz cuvette if you can. Quartz cuvettes are precision engineered sample holders, so you always want to be very careful when you're handling them. Make sure that you're wearing gloves and you're not leaving fingerprints on the quartz cuvette. If you think you left a fingerprint on the quartz cuvette, you should grab a CHEM wipe from the little green box next to the spectrophotometer and wipe down the transparent sides of the cuvette so that you don't leave any finger oils on it. Generally handle the cuvettes as close to the surface of the counter as you can so that there's no chance you'll drop them and break them. And all we're going to do to get our sample into the instrument is fill the cuvette to the top with the sample we want to analyze using a disposable pipette. So for your analysis, you're going to need to take 4 standard absorbance spectrums, and you're going to need to take the absorbance spectrum of the blank 3 times and the absorbance spectrum of the sample 3 times. So what you can see on the right here is the cuvette filled with an aliquot from the 10 mil standard. So you can see this is a narrow channel cuvette, and it took about 1.5 milliliters to fill it. I filled it all the way to the top here, but really for this model spectrophotometer, you only need to fill it about half or 2/3 of the way up because the light beam is actually going to pass through the lower end of the cuvette here. Once you've filled your cuvettes, while still wearing gloves, you're going to transfer the cuvette to the sample holder. So what you're seeing here in the spectrophotometer is we've opened up the lid on the left-hand side, and now there's a sample carousel with a numbered sample holder for each cuvette. 1, 2, 3, 4, 5, 6, 7. So in this model, you can actually put up to 7 samples in the carousel at any given time. And if you tell it that in the instrument that you have 7 samples in the carousel wheel, it will scan the first one, then rotate the wheel, move on to the second one, scan that one, rotate the wheel, move on to the third one, etc. The only thing you want to be cognizant of here is when you put the cuvette in the sample holder, the cuvette has frosted sides and transparent sides. The light path is at the front of the spectrometer. The light from the lamps comes out of this aperture right here, travels across the sample container, and then the detector, which is going to measure the response, is over here. So as a result, you want to make sure that the transparent sides of the cuvette are aligned so that the light will pass through the transparent side this way. You want to make sure that the frosted sides are facing this way because the light won't be able to pass through the frosted sides effectively. Once you have all your samples loaded up, you hit the green manual start button. You fill in the information to let the instrument know in which sample holders you have a sample. And then you hit start, and the instrument will begin scanning. Once a sample has been scanned, the raw data that the instrument will show you is an absorbance spectrum. An absorbance spectrum is a graph of how much light has been absorbed at specific wavelengths. So on the x-axis, we have the wavelengths, which are the energy of the photons that are passing through the sample. And we are interested in taking the absorbance at what's known as the wavelength of maximum absorbance, or the lambda max for short, which is 510 nanometers for our iron phenanthralin complex. So once again, the lambda max is in the green region of the visible spectrum, and so that's why our solution appears red, because it's absorbing mostly green light. We see mostly its complement reflected back at us. We don't want the wavelength, though. We want to know how much light it absorbs at this wavelength. So we're actually interested in the Y value of our absorbance trace at this specific wavelength. So you would come up here at 510 nanometers, you would scroll out and over to the left, and for this trace, the absorbance would be 0.72 at 510 nanometers. So you would record this value, and this absorbance value is what you'll plot against the iron concentration of the standards to make your calibration model. Absorbance is a unitless measurement because it's a log value of a ratio, so it has no physical units. So when you're reporting an absorbance, you'll either see it reported without units, or you'll see it reported with units that read A period, U period for arbitrary units. Just computer units that have no physical meaning. Wavelength, of course, is generally reported in nanometers. And so that's the information you need for each sample. You would take your absorbance value for each sample and make a note of the absorbance value next to the concentration of the standard that you measured to make your calibration curve. Then you would take 3 replicate absorbance measurements on the unknown and 3 replicate absorbance measurements on the blank to get all your statistics. At that point, you're done with the instrument. Before leaving the lab, you should make sure that you exit the remote mode on the spectrometer control panel. And once control has come back to the spectrometer box off the computer, turn off the instrument using the power switch on the back panel below the plug once again. Make sure to empty your cuvettes into the waste, rinse them out thoroughly with the ionized water, and return them to the cuvette holders, once again being careful not to break or crack them. At that point, you would dispose of your iron standards, your iron samples, and your iron unknowns in the appropriate waste beaker, and you'd wash your glassware, and that would be it for this experiment. The rest is all data analysis. So if you feel like you have a good grasp of what you saw in this video here, go ahead and move on to the little quiz that follows the video. If you want to watch it one more time, rewind, go over some additional parts, feel free to do that. But make sure you get the quiz taken for this module, and then move on to the module that describes the general structure of data analysis and how this absorbance data is going to fit into the overall scope of the experience, and I will see you there.